Hey guys, this is Patrick from SDH, and today we're going to take a look at this server right here, which is the Tyan Transport CX GC68B8036-LE. But that is the short name for this product. This 1U server is actually, the technical one is the B8036 G68 V4 E4-HR-LE. Tyan does not subscribe to the idea of short marketing names for its servers. Instead, that's more of a name that basically describes all of the features on this platform. And yes, I definitely looked at the second one because otherwise I would totally forget it. This server is an AMD EPYC 7003 Milan server, and it also works with the 7002 series of Rome processors as well. Specifically, it's a 1U single socket AMD EPYC platform. But I think there's actually a pretty interesting angle, which is why I wanted to look at this system specifically. At STH, we have access to pretty much every kind of server that's out there. And one thing that I think we really haven't talked enough about, especially in our Launch Milan coverage, which you can find a link to in the description below, is just the idea that, well, consolidation is a huge value proposition for the Milan series. When we were in the Intel Xeon E5 V1 through maybe V4 generation, people would talk about being able to consolidate from 2 generations prior, maybe, 1.5 or maybe 2-to-1 ratio. But this, if you kind of go back a couple generations and systems that we actually have in our lab, this can replace like 4 dual socket systems in this single socket server. And that has implications not just on, well, I guess, software licensing and all that kind of stuff, but actually has massive implications on how we design our infrastructure. When we did our launch AMD EPYC 7003 Milan coverage, we really focused on that dual socket market. But servers like this Tyan server are actually designed for a lower cost using the single socket platform to really deliver a lot of the value without all of the added cost and complexity because you don't need a dual socket server anymore. And so the basic game plan of today is that we're going to start at the front of the server. We're going to move our way back, and I'm going to talk about some of the features and some of the cool things in this server. I'm also going to talk about what some of the impacts are. We're going to look at performance, power consumption, and then I'm going to get to just some closing thoughts. So let's get to it. Now, just taking a look at the server, and you can probably see I have the server laid out in front of me. This is not the deepest server that you're going to see. This is 680 millimeters, which I think is like 26.7, 26.8 inches or so deep. So compared to a lot of these servers, especially the dual socket servers that we see, this is a lot shorter of a form factor. If you do have a data center where you have shorter racks, this might be an option where some of the larger servers just aren't going to be an option. A lot of times, those smaller racks also are found in data centers where you tend to have lower cost hosting, and lower cost hosting of these types of things, lower power density and what have you. And so as a result, this actually kind of matches some of the rack profiles that you would expect to see in hosting environments that would use this. Now, looking at the front of the system, what you're going to see is that we have 4 3.5-inch bays. Now, these are specifically hard drive bays. They are either SATA or SAS. However, our system is wired for SATA. One of the nice things, of course, in this generation is that Tyan is using its toolless drive trays. And it's pretty easy to see what's going on if we just pull one out. So you have this little latch and you basically put your drive in here. You don't use any screws. You just latch this together and you're all set. But a 1U system that has 4 3.5-inch hard drives is, let's face it, that's been done before, and so that's not exciting. But what you're going to see is that there's something just above that. Specifically, there are 4 2.5-inch NVMe drive bays. Now, these 2.5-inch U.2 NVMe drive bays, well, they're not able to go fit 15mm SSDs. There's just frankly not enough room. But one of the cool things in terms of SSDs are that you get a little bit of flexibility in terms of your form factor, so you can put 7mm SSDs, and they go into these wonderful little, what I call roller coaster 2.5-inch drive trays. Now, these are toolless drive trays. You might be asking why I call them roller coasters. And frankly, I used to be afraid of roller coasters. I was very, very scared of roller coasters. But the first roller coaster I went on, because I liked a girl when I was a kid, and pretty much she wanted to go on a roller coaster. So of course, all of a sudden I got over my fear and went on that roller coaster. That roller coaster was called Top Gun. It was at a theme park called Great America down the street. And a key theme of that is that you actually hung and you're suspended by the roller coaster from above. Unlike most drive trays where you have something maybe on the bottom bottom or just on the sides, this one actually has a crossbar that goes atop of the SSD. So whenever I look at this, before I had this thought of roller coaster, I always thought that this bar went on the bottom and I would insert the SSD the wrong way. Now I think of roller coaster, and now you will think of roller coaster too, and be able to insert the drive in the correct orientation in the toolless hot swap drive bay. Now, the drive backplane actually has two features. It's one, providing the power and also the data connections to the front drive bays. But there's another feature that is also kind of important, and that is that it actually has all the fan headers that go to the center fans. Now, these fans are actually single units. They're not dual units, at least in this chassis, and they're just kind of held in there. You can see that you can pull them out pretty easy, but then there is a cable that goes from the fan to the backplane. If you're accustomed to super slick hot swap units, then this is definitely a little bit harder. But on the other hand, if you are going to have a system that doesn't have that really slick hot swap functionality, this is actually not too hard to service compared to some other designs where the connectors are really hard to get at. These connectors are actually found to be pretty easy to service. There's another key feature in the center section that we don't really talk about that often, but there's actually a separate power distribution board. So we have our dual 850 watt redundant power supplies. Those go into the redundant power board and the power distribution board, and then power is brought to the drives, is brought to the fans, and then also brought to the motherboard. On all of high-end dual socket systems, what you'll see is that this power distribution is built into the motherboard itself, but here we actually have a separate board. It helps to lower the overall cost of producing a system like this because you can use a motherboard that's designed for a bunch of different systems and be able to have a kind of flexible way that you can power it because you're using this power distribution board instead of built-in power supplies. But now it's time to get to the big feature, which is this section right here. We get a single SP3 socket or AMD SP3 socket, and in that socket we can put either AMD EPYC 7002 or AMD EPYC 7003 series processors. 7002 is Rome, 7003 is Milan. What that practically means is that we can scale from low end, like say 8-core processors, all the way up to 64-core processors. Now, technically, this system is rated for up to a 240 watt CTDP. If you did want to go up to 280 watts, there's a note that you can talk to Tyan about it, but up just kind of standard, you can go up to a 240 watt CTDP. We don't talk a lot about the CTDP, but basically what happens on an AMD CPU is that a lot of them give you the ability to run at the base TDP levels, but they also allow you to extend the range of power that you can put into and heat that you can generate out of a chip, and you can go up to a 240 watt CTDP. You don't get more cores, but you do allow the turbo clocks to kick in for longer and at higher ratios, and so that's something that's just kind of nice because you basically get, by flipping a switch, a little extra performance in a system like this that can support 240 watts versus just 225 watts. If you do have a system with a CTDP part, I would strongly suggest that you just go look at that setting and decide if that's something that you want to take advantage of, because you can get a little bit more performance and it's basically free other than the power consumption. Now, this socket sits on the Tyan S8036 motherboard, which means that we actually have kind of standard-ish building block for a lot of Tyan systems. But one of the cool things is that the CPU is actually in the middle. By putting the CPU in the middle, that means that we get a lot of room on either side of the CPU to go put DIMM slots. While there are some motherboards for single socket EPYC that only have 4 DIMMs on either side, so 8 channels of memory and 8 DIMM slots total, this actually has a full complement of 16 DIMM slots. What that practically allows you to do is really raise the amount of memory that you can put in a system using lower capacity DIMMs. And by using lower capacity DIMMs, you generally have lower costs. That doesn't necessarily work if you want to look at something like an 8 gig DIMM, then really putting 16 8 gig DIMMs doesn't make sense. I would just put 8 16 gig DIMMs. But once you start doing things like you start looking from going from like 32 gigs or 16 32 gig DIMMs up to 8 64 gig DIMMs, you're definitely going to start seeing that there are some pricing differences. Of course, the big one is going from 128 gig per channel, or DIMM per channel, where you would have 8 of them in a system for 1 terabyte, and going to 16 64 gig DIMMs. That is a huge price delta, or a very large price delta in comparison to the system. And so it's a good example of where that's useful. Now up here, you're going to see that there's actually a whole bunch of depopulated components, which is part of the -LE portion of the model name. What that basically is Tyan is removing all of the connectors, and they're actually relatively pricey connectors for the high density PCIe Gen 4 lanes that would come out of here. And so instead of actually populating those, Tyan is saving the cost, which brings down the cost of the overall system. I know there are folks that may say, well, that's kind of a bummer. We don't get the advantage of having those extra lanes. But in a system like this, there's really only so much expansion that you get. So it's just kind of cost savings by them not putting it there. And since you can't really use it anyway, I guess it makes sense. Now, behind the CPU and the memory, what you actually have is all the expansion. And what you have is you have two M.2 NVMe drive slots. I think they're PCIe Gen 3 slots. Now, out of those motherboard PCIe slots, what we get is we get a riser. And that PCIe riser has two slots because there are two different sections. You get two PCIe Gen 4 by 16 slots. And so you can do things like put two, say, 200 gigabit Mellanox ConnectX 6DX NICs into each of those. So you can have two 200 gig NICs for a total of 400 gigs of Ethernet bandwidth coming out of the server if you just really wanted to go do something like that. That's something that you couldn't do in the PCIe Gen 3 generation because, well, a by 16 slot can't power a 200 gig Ethernet slot by itself. So that's a good reason. One thing to note is that these are only half length. They're not full length card slots. So you can't do things like if you wanted to go put like a NVIDIA A100, full length card, you just couldn't do it in something like this, but you could put something, say like an NVIDIA T4 or something that's kind of a smaller, lower power card in a slot like this. In terms of networking though, it's not just these card slots. You can actually just use, there's an OCP NIC 2.0, so not the newer 3.0 standard, but you have a 2.0 standard NIC that you can go put in here. And so it's not, the nice thing is it's just not a custom mezzanine or anything like that. There's tons of OCP NIC 2.0 cards out there, so it should be pretty easy to go find something for this. For networking, there are two 1 gig Ethernet ports. And one interesting thing here is that these are not Intel-based ports. They're actually Broadcom BCM 5720 NICs that are on the back of the system. So you don't necessarily get 10 gig Ethernet, you get 1 gig Ethernet. But frankly, I think that if you have a EPYC system these days, you're most likely going to be deploying at minimum 10 gig Ethernet, which you could put in the OCP NIC 2.0 slot. Or if you're going to go to faster Ethernet, you have plenty of options to go do that as well. Some of the other little tiny features that I figure we should talk about are that we actually have a USB 3 header. So there's an internal type A header. If you want to go put a license key or I don't know, something on a USB thing there, you can do that. There's an SD card slot. And then there is one other little feature that we should talk about, which is that there's a Marvell SATA controller. And that Marvell 9235 provides the SATA functionality. So this is a little feature of this motherboard that's just a little bit different. And rounding out the rear features, we have our two 1 gig Ethernet NICs. We have VGA, we have serial, we have USB, and then we have an out-of-band management port. This does use an ASPEED AST 2500, and Tyan uses a pretty industry standard Megarack SPX solution for their management interface. And this is a standard BMC, which is an AST 2500. And so overall, it's just kind of an industry standard solution to do management. If you want things like an IKVM functionality or HTML5 IKVM functionality, this has you covered. Overall, in terms of hardware, personally, I think this is a really interesting platform. And let me tell you a little bit about why and why it actually makes a lot of sense to me. And it's something that I feel like we just don't cover enough when we talk about EPYC. Something that you will definitely notice if you look through the AMD EPYC SKU stack is that they don't really have the low-end SKUs. In fact, in the AMD EPYC 7003 series Milan series, basically AMD didn't launch. They, I think, had one 155 watt TDP CPU, but they didn't have anything that's lower than that. And for its part, I guess Intel has parts that are like 85 watt parts and, much lower end parts. And so a lot of people ask, well, why doesn't AMD have those low end parts? And the reason for that actually is something that, I found out impacted us when we tested a server like this. And I think it's definitely something that our readers and you on YouTube should look at. Specifically, we have these 2U 4-node chassis. So there's a total of 8 CPUs in 4 nodes, dual socket nodes. And so that's kind of how we get the 8 CPUs. And each of these nodes we basically just use, and they're really with low memory configurations just because we need cores for low generation nodes in the lab. And so each of these nodes is basically set up with an Intel Xeon E5-2630 V4, which is not really a high-end part. It would be basically equivalent to like a Xeon Silver or so in the current Xeon stacks. And because we had 4-channel memory, we had 8 gig DIMM sticks in each of the DIMM slots, which meant that we had 8 gig DIMMs in all of these systems, which meant that we had a total of 64 gigs of memory in each of the 4 systems, or 256 gigs total. Now, given, the, say, 3 to 5 year replacement life cycles, that E5 V4 system is a high volume system, and it's one that you would be replacing today. So when we think about that server, overall, we had 80 cores total and 256 gigs of RAM in those 4 nodes. We also had to have networking for all that. I mean, there's a lot of complexity in just the fact that we had 4 nodes instead of, 1. And so AMD's value proposition is really to say, hey, look, you could have those 80 lower performance cores plus your 256 gigs of RAM, or you could just get a single socket, one of our AMD EPYC 7003 series. And there are CPUs like the discounted P series CPUs, like the 7713P, which is a discounted 64 core part. And basically, we go down in the number of cores from 80 to 64, but we get a lot more performance per core. And then we can also easily put 64 gigs, or we put 32 gig DIMMs in here, and we can end up getting to 256 gigs of memory or more. And so we actually tried it out with this system in our lab, and we just wanted to see, well, could we do single socket AMD EPYC versus our, lab node, just low generation nodes where we had our, 4 dual socket, 10 cores per socket systems. Could we actually go and replace that? And the answer is, yeah, we could, no problem. One of the other really interesting things is that not only do you need less networking because you don't have as many uplinks because you have 1 server versus having 4, but then also the communication between all of the, different parts that it would be running on all of those different nodes. Well, instead of going over the network, hitting a switch and then coming back to the other node and then going through the NICs and the process that way, everything's all in the same system. So by having a bigger radix, that kind of helps our overall performance. And that's something that we don't talk about it a lot in reviews because we always look at single system performance. But when you kind of get to that network level, having more concentration around fewer sockets and fewer systems is actually really beneficial. So something that we noted and others noted in the industry was saying hey, the AMD EPYC parts, they actually use a lot of power at idle. But when we looked at this system versus that 2U4 node system, which is actually a relatively power efficient 2U4 node system, what we found was that this actually uses way less power at idle and also uses less power when it's fully loaded. So basically, we got a 4-to-1 server consolidation ratio, an 8-to-1 CPU socket consolidation ratio. We got a 4-to-1 NIC consolidation ratio. We also didn't have to have all the boot drives and all the extra stuff like that for multiple systems. So there's a lot of cost savings by going down from 4 server nodes to only 1. And by doing that, we actually use less power both at idle and under full load while also getting more performance. So overall, I would say that's a pretty awesome trade-off that I would take any day. Now, there are a lot of server reviews that are done that really look at just if you just need the maximum performance per node, you're going to go buy the highest end SKUs. And that whole idea of scaling up in terms of performance, sometimes you just frankly don't need to scale up a whole bunch in terms of performance. Sometimes you have workloads and platforms where it's if I can basically get the same thing from going from 8 sockets and 4 servers down to a single 1 socket server, well, that's fine. I just have a lower footprint, and that means that my power bill in the data center is less. And keeping the single socket configuration means that the nodes just don't get too big. And at the lower end of the market, well, take that Xeon E5 V4 example. You can go and without even going to the 64 core CPUs, when you go to the 32 core options or lower, you can basically take the vast majority of the Xeon E5-2630 V4 series dual socket nodes and move them into a single socket node just like this one. In fact, if you're running with just 1 DIMM per channel or you're running 2 DIMMs per channel, you can have the same number of DIMMs, and most likely today's DIMMs are higher density than the older generation DIMMs, so you can get more memory capacity as well. That consolidation at the low end of the spectrum, really all of those kind of lower cost servers that used to be very popular and still actually are extremely popular. Basically, AMD isn't saying, well, we're going to go make a CPU that you can put 2, you can do a dual socket server, put 2 CPUs, and well, that's how you're going to go 2 socket to 2 socket versus Intel. What they're basically saying is you don't need 2 sockets. We're just going to give you 1 socket, and you're going to reap the benefits of that. Overall, the reason I want to take a look at this system isn't because it's the fastest, highest performance AMD EPYC 7003 series Milan server out there. I mean, let's be real. This is only a single socket node. You're really not going to go put a whole bunch of super high powered GPUs in it. This still uses hard drives, and if you really wanted performance storage, you'd probably get the version of this with the 2.5-inch bays instead of having these 3.5-inch, hard drive bays up front. And there's a lot of different options, and frankly, Tyan makes a whole bunch of different boxes that can really handle all those different types of workloads. But this is very specifically targeted, and I think taking out many of those dual, Xeon E5-2630 V3, V4, whatever they are, installations, and putting them onto a single socket EPYC platform. And not only is it looking at going 2-to-1 in terms of socket consolidation ratios, we even saw in our lab that we were able to go do 8-to-1 and 4 server nodes to a single server like this, which is actually a cost-optimized AMD EPYC solution. While we all love to go talk about the super high end of all of these lines, I actually think that platforms like this, the single socket EPYC platform, is absolutely phenomenal. I mentioned earlier with the Naples generation, many of the vendors didn't really realize that the single socket solutions were going to be popular, but yet that was an idea that I think AMD had the foresight to say, like, hey, we actually don't need to do dual socket anymore. We can just do single socket. Intel has followed in kind, and they now have a U series, which in server world is different than in kind of normal desktop world, where U series in Intel means that it's single socket. It's just confusing. I don't know why they couldn't just use P as well. But the industry is starting to realize that there's this idea that you can actually go consolidate to single socket systems, not have to go deal with those numino differences, and get lower cost nodes. Also, as CPU TDPs rise, what we're going to start seeing is that some organizations will have to go to single socket nodes because that really fits more of their rack power density better than if you go to dual socket nodes in these newer generations. It's just part of computer architecture evolving. So I don't necessarily think that this Tyan Transport CX system is the fastest system that we're ever going to review, but I actually really just like the fact that it's one that we could literally take and consolidate 4 of our systems down to just this one. At some point, servers just get old, and when you're looking at the new generation, I definitely think you should look at the single socket solutions, especially if you're running something in that kind of lower end Xeon E5 range or even Xeon Silver. I think consolidating down to a single socket might actually make a lot of sense. Hey guys, I hope you enjoyed this video. If you did, why don't you drop us a like, click subscribe, turn on notifications so you can see whenever we come out with great new videos. As always, thanks for watching and have an awesome day.